Do you think voltage ratio and turns ratio mean the same thing? If you do, you're not alone. But there's a small difference that makes a big impact in transformer calculations. Let's clear it up in under 3 minutes. Hello everyone, welcome back to the channel. Today we're going to understand the difference between voltage ratio and turns ratio in the simplest way possible. If you're working with transformers, generators, or electrical design, this idea is fundamental and will save you from a lot of confusion. So let's jump straight in. Turns ratio is simply the ratio of the number of turns in the primary coil to the number of turns in the secondary coil of a transformer. Formula: turns ratio equals number of primary turns divided by number of secondary turns. This formula is displayed prominently on screen. Example: if the primary has 1,000 turns and the secondary has 100 turns, the turns ratio is 10:1. This is a physical property of the transformer. It depends only on how the transformer is manufactured. It never changes unless you rewind the coils. Voltage ratio is the ratio of input voltage to output voltage. This is an electrical result. Formula: voltage ratio equals primary voltage divided by secondary voltage. This formula is displayed prominently on screen. Example: if input voltage is 230 volts and output voltage is 23 volts, the voltage ratio is 10:1. It depends on supply voltage, and it can change if the input voltage changes. This highlights its dynamic nature. Let's compare. We'll look at turns ratio versus voltage ratio side by side. Turns ratio is about physical design, a fixed value, set by manufacturer and coil-based. Voltage ratio is about electrical output, can vary, depends on supply, and is voltage-based. In an ideal transformer, the voltage ratio is equal to the turns ratio. This is a key principle. Why? Because voltage is induced by electromagnetic fields, and more turns means more induced voltage. So, voltage ratio approximately equals turns ratio. This approximation is crucial for understanding. But in real life, small losses from resistance, flux leakage, heating, and load current cause a slight difference. These factors mean that the ideal relationship is rarely perfectly achieved in practical applications. So remember, turns ratio is about coils, and voltage ratio is about voltage. They are usually equal, but they are not the same thing. This distinction is vital. Understanding this can prevent major mistakes in transformer selection and design. It's a fundamental concept for any electrical professional. If this helped you, hit like. Comment any doubts below. Subscribe for more easy engineering concepts. Thanks for watching. See you in the next one.